All right, guys, do you have any questions on anything? Not really? Cool. So we are going to start a new project starting from today. And you have about very close to 3 weeks to work on it because this is a little bit challenging, I think. There are several things you have to figure out. For first, how to get a new Arduino Nano to work. It's not like Arduino Uno. You can directly upload the code from the GUI. You have to burn the bootloader here. Just have to follow the little tutorial on the right-hand side of the original tutorial. So when you buy a new chip, like a new Atomega 322 from DigiKey, usually there's no software called Bootloader in there. So you cannot directly communicate your chip with your Arduino GUI. So you have to burn the bootloader into the memory into your microcontroller. So this one shows how to burn the bootloader, which communicates with your serial port on your laptop with the microcontroller chip. It scans the serial port like every several seconds. So it's monitoring if there's some commands trying to be uploaded to the chip. So this is a piece of software which is called Bootloader doing here over there. If you don't have a bootloader, when you click upload, it's going to stop there forever. So it's very frustrating. So this tutorial, if you go back to the original schedule here, it's over here. Click it, and get into it. And the top, there are two halves. On the top is showing you how to burn the bootloader into your dip version. So 322 TPU, that's the name of it. It's a 22 pins. There's no difference from this one and the surface mount version. So it's the same die. I think it's exactly the same design, but they put in a different package. So this is the 22 pin dip package. This is how you burn the bootloader into it. If you're picking up a new one from the drawer, I have a drawer of 328 deep version microcontrollers. I have like 100 in there. So if you grab a new one, you have to burn the bootloader first. Otherwise, it's very difficult. But for the ones you grab from, you take out from the Arduino Uno board, it already has the bootloader in it, so you don't have to burn the bootloader. That's why you can directly, grab and upload your code to the microcontroller. It's different. If it's a new one, you bought like 100 from DigiKey, you have to follow this tutorial to burn the bootloader to the chip. So this shows you how to do it for the dip version. And if you scroll down, it shows you how to do it for the surface mount version. So this is called 322AU. And so for the projects I'm working on for the company, the external contractors, I usually do not use a dip version at all because it's the same chip, but it's a lot bigger and just looks like a 1970 technology. So all surface mount, if I can, right? So usually they are surface mount. So I have to consider the surface mount version. You have to download the bootloader, the piece of software, to your functioning Arduino board first, which is a Uno board, and then communicate between these two, a regular Uno board and a Nano board, to send the bootloader from here to here. Okay, this is how to do it. It's very simple. Make the connections, change the port. So should be able to get it done. So the Arduino Nano board in a drawer, in a little box, doesn't have bootloader in it. So I have to follow this tutorial in order to make it work, right? That's the first thing you have to do. And the goal of this project is to create one node, just one single node. We are not just trying to create a network of temperature sensing. It's an application of Internet of Things. So all these devices is a server itself, and it is able to sense the temperature and send it to a server, IoT server, which is called ThinkSpeak. There are so many different servers, and you don't have to use ThinkSpeak. You can use all the many different versions of the IoT servers. And so every single node is going to sense the temperature and send it to the website, and you can directly visualize the temperature on the panel of the website. So it has a GUI on ThinkSpeak's website. And for the next step, which is, you have to use Python to design your own customized GUI to acquire data from that server. So there's a get something command from Python. You can directly acquire data from the hub, from the IoT server, and display. You can design whatever GUI you like. You can customize it, and eventually display all the temperature on your GUI, but not on the general purpose IoT server. You have to pay for it, right? I forgot how much, but I think if you have 24 nodes, it's free. But anything over that is like a few $100 a year to use ThinkSpeak. But for a big company, it usually doesn't matter. Like $200 a year is nothing. But you can, for the engineers in the company, if they want to manage the data by themselves, they want to use their panel, right? They want to customize the panel just for to serve their purposes. So you can use either C++ or use Python to design the GUI to acquire data, like them, and even plot them in real time. So this project was from the Polkadot Spring temperature sensing project, and I used a different packaging of the sensor, the temperature sensor, but it's the same core. It's the same 3-pin, power ground data. It's just 3-pin. Also, it's called one-wire temperature. It's very famous temperature sensor in the computer engineering field. Everyone knows it, but you guys should know it as well. I think it's super convenient. Just one wire does everything, clocking data and everything. It's just amazing. I2C still has 2 pins, right? It's a SDR and SDA, but this guy, 1 pin, does everything. So you want to use it. You want to know how to use it. First, you have to use the surface mount version, because in the PCB design, you must know how to use this one to be familiar with the pinout of the 328 AU version, not the DIP version. And this is a crystal. You have to know how to solder it, how to design the package of it as well. And these are the only 2 things you need to run a bare-bone microcontroller. Just keep in mind. Definitely, you need a push button to pull the reset pin up to VDD, and definitely you need a power and ground. So one quick question: what's the power? What's the voltage for this chip? 5. I just told you it's the same chip as the DIP version. So whatever you used over there is same ground, same power, same oscillator. You can even use a DIP oscillator, because everything is surface mount. You don't want to use the oscillator is like pretty much the same size as the chip. It looks not really good. Taking baby steps. Usually when you start a new project, think about how many components we have. You have a Wi-Fi module, which is a ESP8266. You have a microcontroller, which is the nano board. You need a little OLED display, and you need a temperature sensor, right? These are all the components. And you want to figure out each one step by step. So for example, see if you can communicate with the temperature sensor first. So your Arduino Nano board can acquire temperature data and show it on the serial display monitor. So you know temperature sensor works, right? Then start with another thing, the OLED. It just send a constant to the OLED, so you'll know that your Nano can communicate with the OLED display module. And then connect your ESP8266, which is a Wi-Fi module, to your Nano, and also again send a constant. See if you can send it over to ThinkSpeak. Just displaying a constant. You don't want to add too many variables to the system at once. For example, you are sensing the data. You want to send the temperature data to Wi-Fi, and you don't know if nothing works. You don't know what's going what is wrong, right? What's going wrong. So it's better to configure each one step by step and then put them together, so you'll know whenever the whole system is not working, you know what's going on. Right? It's easier to debug. So follow the tutorial, you can see that the first one I picked up is the communication between Nano and the 1306 OLED display. It's also a very popular one. It has a functioning library you can directly use. So you don't have to program the very bottom level header files. So make sure it works. Guys, this one also shows you how to load the library, how to display something on the OLED display. So this is the 21st century technology, right? Not the 7-segment display, which was from, who knows, like the 50s. Second World War, probably they already have the 7-segment display by that time. And try to display whatever you think you want to display on the monitor. Okay, so all the code here is provided. You can directly copy and paste and try to repeat the work. And then communicate with DSP, DS, not DSP, sorry, DS 1820. So this is the dip version of the sensor. And I believe there's a surface mount version, but we're not using it. It's difficult to plug into the board. It's not for prototyping purpose, but this one is good. Have to use a 3.3 volts. Keep in mind, I believe this is 3.3 volts. 5 volts probably will blow it up. Keep in mind. Yeah, connect the sensor to Nano. It's a room temperature, right? And next, getting 2 of them together, sensing the temperature and display it. Okay. And then, since when you are adding too many components to the one single CPU, you have to consider using ISRs, right? Interrupts, too many tasks. So if you put everything in one loop, there might be some issues. You want to use interrupt, you know, checking if there are any changes, or if you want to update the data, you know, after every like 1 second or 2 seconds, things like that. So you want to involving ISRs. It worked. And again, have to consider the power modules. So what did I put here? So the ESP8266 is a 3.3 volts module. So when you are connecting, so Arduino Nano receives temperature data from the sensor, and it sends the data to the Wi-Fi to ThinkSpeak to the server through this Wi-Fi module. See? Using what? Using UART. So UART is not the same just for downloading your program from the laptop to the microcontroller, right? You can use it for any digital communication as long as both of the devices have the UART module in it. So RxTX communicating with ESP8266, RxTX, but only have a voltage divider on one direction. Why is that? But just for here, because the TX is sending something, right? Sending data from the Arduino, which is a 5-volt logic. So it's going to send in 5 volts signals to Rx of the 8266. However, it's going to blow it up. So I have to divide the voltage by this, right? 1K, 2K is 2/3 of the voltage. 5 volts is something around 3.3 volts, which is acceptable for this 3.3 volt device. But the voltage from here to here, you don't have to do anything because it's right at 0.3 volts, sending out from the 0.3 volt device, and the 5 volts receiver will treat 3.3 volts as the voltage high. So that's fine, right? 0 is always 0, but 3.3 volts is higher than 2.5 volts, which is the threshold voltage of the transistors. So still voltage, still logic high. This is something you have to do. Otherwise, you have to keep replacing your Wi-Fi modules. OLED is also a 3.3 volts logic device. So you must use both modules. Since you have your power supply, right? The power supply PCB, if it's functioning, when you are doing the testing, you can directly use your power module for prototyping purposes. But later on, you still have to merge all these regulators on your own PCB, right? Actually, one more quick note. I used this one and it worked really well. And I even used the IR camera to look at the temperature of the regulators, and I didn't see any overheating or something. But it's very interesting because people are saying this Wi-Fi module, because anything like is transmitting wireless signal is actually very power consuming. So this Wi-Fi module is consuming over like 600 milliamps, and some people say like whenever it's fully on, it can consume over very close to 1 amp. So these devices are 1 amp regulators. It may not be the best choice to power up this guy, but I didn't see overheating when keep it on for a couple hours. It's still not overheated, so it might be fine. I think the reason why I don't want to use the 3 amp regulator is, do you know how much is it for the 5 volts regulator? Like over $7 for one. But if you buy that module from Amazon, the module has everything on it. It's just $3. I think the manufacturer in China who made the PCB with all the parts on it, they probably bought like 1,000 chips one time. So that's why I can bring the cost down to $3. What I'm thinking is probably can buy these modules and desolder the chips and I don't know. It's ridiculous. Like $6.7 from DigiKey to buy each of the 5 volts regulators. This works, so let's just use these ones. These ones are like lower than $1 for each, and it's not overheating, so it's fine. So this is the ESP8266 module. You don't have to redesign the PCB. It's very difficult to do any RF PCB design. You can look at the antenna here. I mean, if you make the antenna a little bit different, probably it's going to change the bandwidth a lot. So you don't have to touch it directly. It has the pins. Directly design the pin headers, the female headers, and just directly plug in. Right? Do not redesign the ESP module. So this is the pin out of the module, and it shows you the connections from here to here. So I have to, before we put everything together, I have to do the testing first. So what is this one doing? It's pretty much the whole system already, right? Sensing the temperature to the display and at the same time send it to the Wi-Fi. So the ESP module is able to connect to the router in the room and send it to the IoT server, which is ThinkSpeak. Okay, so this is a diagram of the whole system. And you can see that I used 2 microcontrollers. Is that correct? Yes, I did. Why? I think there must be some interrupted conflicts, so I have to use 2 of them. One is for temperature sensing and OLED display. And another one is for Wi-Fi communication. And in between them, I think I know why here. So here's I2C connection. That's I2C protocol. Because the OLED display requires I2C, and there's only one I2C module on it. Do I need I2C somewhere else? No, that's the only I2C I need. I think there must be some conflict on interrupts. That's probably why. Okay, so 2 microcontrollers on it. It must not be the best option because it's not really difficult system. I think one CPU should be good enough. But you know, just follow this tutorial. I think right now it's okay. It's all right. So these are the display on ThinkSpeak, directly snapshots from the website. It is able to show the temperature data in real time. So it's not updating the temperature like really in real time. It's probably has a 2 seconds, 3 second delay. So for example, you're changing the temperature here, it takes about 2 seconds to show the updates on the website. All right. It's not very challenging to just follow the tutorial. Like, all the scripts are provided. You just copy and paste. I just need to make the correct connections. So that's why repeating everything here is only 80 points for the whole grade. What I'm trying to do is, so think about the real world application. If you have everything designed on the PCB and put in a box, so what if the Wi-Fi password on the property is changed? How to update it? You want to grab Arduino board without the chip plug-in on that and wiring and reprogramming every single one. They are changing password every 6 months. So it's a lot of work. It's not difficult for you guys to do it. For the any of the workers who do not have any computer engineering background, it's very difficult to ask them to wiring your programming pins, TXR pins to the chip and program them using open Arduino GUI and making changes to the code and upload the code every time, every 6 months. So what I'm trying to do here is to change the password using push buttons. But I have to display the password in real time on the display. So this came from the real product, the printer. So the brother printer, only $120, which can do a lot of work. But the thing is, it doesn't have a keyboard on the printer. It only has like 3 push buttons. So when you are changing the Wi-Fi password on the printer, you have to keep pushing 1, right? So you have to get into the menu first. So change the menu and get into Wi-Fi password changing. Get into there, and then start typing your password in it. If there's no keyboard, how to do it? I have to use a push button. You push it once, it's showing an A. You keep pushing that, it's changing from A to like 9, like 8 until like Z, and then 0 to 9. And then you stop pushing it, so the cursor stop blinking, and so you can move to the next one. Keep pushing it until you see that letter. This is not the best option, but if you make the password not really long, it should be okay. I'm thinking like on their property, they have all this management stuff, being hired. So if there are 24 nodes, and it may only take like 2 minutes to change the password for each one, so it won't be like it will be less than 1 hour to change the password for all of them. It's definitely not the best option. So what I'm thinking is, in the future, is there any other way? Like they have a GUI, like being controlled by your iPad or something, and you can directly change the password over there. So it is able to update all the password on each node of the sensing system. It's going to be a totally different system because you're thinking about the communication, it's not just uploading but also receiving. You must have an operating system on the microcontrollers. It's a bit difficult. But if you keep it low cost, just use push buttons to change the password. It's very doable and low cost. That is task 4, and task 5 is a PCB layout and design. So this is the second PCB we're going to do for this semester, for this class. And I'm going to submit your PCB design and let you guys solder surface mount microcontrollers on it. Not only the 1970s technology, but also something like really, to look at it, you know it's a 21st century product. Okay. There's a reference. I think one of the students didn't finish the whole project, but it was very close. So if you click this link, it directs you to his project report. And I didn't test it, but seems to me that it's very close. It's very close to the final version, like using the push button to change the password. It may already work, I don't know. But you may want to, change a little bit on the design. And I think the scripts are provided. Hopefully it worked. Yep. They're all there. Again, I didn't test it. Seems to me it worked somehow. Just trying to change something here, right? There are some options like going back, access point, password, okay, things like that. You have different layers of menus and different options as well. So if you just directly, for example, it works, right? You just directly copy and paste and didn't make any changes, I won't be very happy about it. I hope you guys can, step onto the shoulder of the previous students and making a real product out of it. Any questions? I think next time, if I'm teaching this class again and letting students working on this project, I'm going to add the customized GUI into this project. So it's going to be a full product. Because you cannot just let them use a ThinkSpeak panel, right? It's just like the box is too big. You cannot customize a lot of details. It's just not the best option. No other questions? Are doing good? Great. Give these boards to you guys.